Okay. So, this is it. This is the final week, and we're gonna go through the final volatility challenge. It's probably gonna be pretty short, as long as I can, I don't know, remember all the commands and everything. Hey, how's it going?
What up, dude?
Too much. Just starting the thing. Starting the thing. Can you see today?
Nope.
Awesome. I love that. Okay. How about now?
There we go.
Cool. We'll just jump right in. I think this is gonna be uh pretty quick. Pretty quick. Pretty quick. Um, it's a pretty short section. And there's only one challenge lab, so. But anyway, we're going to be using volatility to go through this, the volatility framework um, for memory management. What we're going to do is inside of this Google Drive, there's a um, like a VMware memory file. I think it's just a .vmem, um, and so that was like processes that were running in RAM at the time. Um, the VM was like active and being used. Got volatility 3, we're going to use 3. There are other versions, there's 2.6 and 3, we're going to use 3. The volatility memory extraction framework. Volatility is the world's most widely used framework for extracting digital artifacts from volatile memory or RAM samples. The extraction techniques are performed completely independent of the system being investigated, but offer visibility into the runtime state of the system. So it's pretty cool. Pretty cool program. Hey dude, good to see you. Taking a break from Oblivion. I saw. We cannot hear you if you're talking. I see you unmuted though.
How's that?
Oh,
Better?
cool. Yeah,
Oh
absolutely.
yeah, there we go.
Yeah,
No, yeah, man, Oblivion's been great.
yeah. I played it for an hour yesterday, and I don't know. It was fun. I'm trying to do something I haven't done. Uh, Typically it's always magic or stealth. Uh, this time I've chosen an orc and going like
Going
shield
full
sworder.
caveman on him.
Mhm. Yeah, I thought about berserker type thing, but I don't know. I think unarmed would be cool.
Yeah, be careful though. I found out the other day that there's a bug that will sometimes just wipe your save if
Mm.
you're not careful whenever you go to close the game. So I've had it open for probably 5 straight days.
Oh wow.
Yeah, I don't dare close it.
Dude,
Um,
that's a lot. That's a long time.
Yeah, I'm kind of scared because I
Mhm.
closed it so I could listen to you guys, and
Yeah.
oh, I might be
Classic
starting over.
Bethesda.
I know it.
Hey, it looks cool though. Like it's really cool. I don't know. I
Hmm.
like that they just didn't string you along, right? It's like
Right.
it's just hey, it's here.
Out of nowhere, yeah.
Yeah. That's how they should do games from now on. I bet the hype was just overnight, out of nowhere.
No, it was crazy, man.
But yeah, let's work through this real fast. It shouldn't take too long. And I don't mean
Sweet.
like
Let's get
last
it.
time where it took too long, where I didn't think that it took too long, and it was like an hour and a half. Um, so we're gonna use volatility. Volatility three. Volatility three is for managing, not managing, but looking through RAM volatile memory. We're gonna go through a vmem file, challenge.vmem, which is like VMware's memory. It was like this is like the memory that was on that was running on the machine um, at the time that it was active. There are two other formats for the files if they're like snapshots. But anyway, let's do the instructions. A system administrator at Earthworm Solutions recently dusted off a memory capture from a Windows workstation that was suspected to have been compromised. Unfortunately, nobody at the company can remember the details of the incident, and they now require someone to investigate the capture for signs of suspicious activity. Your task is to test out your memory analysis skills by examining the challenge.vmin file and then analyzing it for anything out of place or indicative of malware. You will need a password to extract the challenge file. The password is infected. The challenge file is in this Google zip drive, and the password again is infected. I've already downloaded it, and I pulled up a bunch of volatility cheat sheets because I thought that they were helpful. And I'll post them into the Discord a little bit later, just to, you can kind of choose what you want. If you're going to go through the exam, this is how I recommend having your notes, like commands. You need to have little cheat sheets like this that are very straight to the point and have just commands in them. Maybe like a little snippet about what it is or what it does, or just something that gives you enough information so that you know like when to use it, or something that allows you to use key terms. Because if you're sorting through something like this at the time, yeah, it's a lot of information, and it's just really hard to, I don't know, search through everything. Although, the keywords searching is pretty great, but having just like a cheat sheet like this is very, very useful, very useful, and it's primarily
So
what I use.
with that in mind, so from what I understand, it's basically just a big open book test, or
It
rather, not
is.
even open book, but open internet
It
test. You could
is.
just, okay, cool.
Yeah, yeah. So TCM is one of those that uh, they treat you like you would be treated in the out in the wild if
In
you
the
were
forest.
in a role, right? Because you have the entire
Right.
internet to use at all times, and they believe that you shouldn't be bound by like some kind of arbitrary rule. Some places use it to like inflate the difficulty, and I imagine
Right.
with like AI and stuff, they more places are probably more likely to do that because it's just sometimes it just I don't know, it doesn't make you think, right? And sometimes they like so that
Right.
you have to think through the processes like to build that methodology, and I can understand
Right.
that. Anyway, let's take a look. So question one is, what was the system time at which the memory dump was created? I think that we can get this um, by using one of these models. I guess first maybe what we should do is opt volatility. Um, so I downloaded it from GitHub, and then I just created an alias, um, which was in my like Z shell file, zshrc, grep alias. So here it is, and that's so that I only have to type volen instead of the entire path, or be in the actual path. So you can do the same thing if you want. You can just nano into, or vim, or whatever you feel like using, into the ZSH file, or you may actually have yeah, bash rc if you're not using Z shell. So we'll use vol, and we have all of these like modules, plugins is I guess what they're calling it. Please select a plugin to run. We're interested in Windows plugins. Thought that would work. Okay, cool, kind of. So because the challenge is a Windows operating system, we can scroll up. It's kind of hard to see, but Mac. So they have Mac, Linux, Windows modules. I am unfamiliar with most of this stuff, specifically because the course only went through the Windows plugins, and not all of them. But what we'll do is clear that off in vol. We'll call the file, which is challenge.vmem, and then we should be able to use windows.info to pull back some information about the challenge file itself. And what it's doing through here, you see like the progress is moving. It's actually looking through all of the data and pulling out bits and pieces. So the system time, which I think is what is the system time? The system time is right here. And I think that this is UTC time. Please don't quote me on that. I believe that it is, though. It probably is. Yeah. And then what is the major minor versions of the system set to? And it's right here, major minor version 15.19041. And then what is the name of the processes that appear out of place? So we can take a look at the processes with PS list, PS tree, and there's another one. PS scan. I want to tell you that I know the differences between them, but I don't. So let's just look at one and see if we can find what the processes are that appear to be malicious or out of place. Hopefully this won't take too long. God. There's so much information here. What if yes, let's just look through some of these. It doesn't seem very easy to look through. At least like this. So, but we can see we've got the process ID, the parent process ID, and the image file. And I believe that we'll end up seeing that same thing here as well with PS list. Yeah, so we're going to use the PS list module. It's just easier, I think. There's less information. It looks like, let's see if we can tell a difference. Time in UTC. I don't know. I don't know why it was, why it's so much bigger, or why the information is like that. But looking through, we see registry, smss.exe, csrss.exe, WinInit, WinLogon, services, LSAS, font driver host, SVC host. I don't know what that is. I don't know what DWM is. VirtualBox, mem compression, NIS, SRV, task host, Explorer, so on and so forth. I'm just gonna kind of cut to the chase here. When I was looking through this the first time, I saw these at the very beginning, right? Because they were just here. And then as I scrolled up to the top, I see this csrss.exe and then crss.exe. Yeah, and I thought that was weird. I was like, why are these two? Why are they so similar? And then just looking, let's see, csrss.exe. Probably not a great question. Yeah, I don't. And we can use this answer, I think. Maybe, let's see if there's one for, that'll take us to a Microsoft article would have been nice. This is probably not great. Yeah, not exactly what we're looking for. I guess we can just look at this Wikipedia page. So the CSRSS is a component of the Windows NT family operating system that provides the user mode side of the Win32 subsystem. So this is like one of the first programs, first processes to start, along with WinLogon, SMSS. Honestly, a lot of these that we see up at the top. It starts pretty early in the process, and so we expect to see it up there early on. CSRSS runs as a user mode system service. When a user mode process calls a function involving console windows, processes, thread creation, or side-by-side support, instead of issuing a system call, the Win32 libraries, kernel 32, user 32, GDI 32 send an inter-process call to the CSRSS process, which does most of the actual work without compromising the kernel, without manager and GDI services. So I think from here, we're pretty safe to say that it's a valid process. And you can see here, there are numerous virus hoaxes that claim that CSRSS.exe is malware and should be removed to prevent damage to the system. These are false, as removing CSRSS.exe or killing the CSRSS process will crash the Windows operating system. So if the CSRSS file is like corrupt in any way, it won't allow the computer to boot, and it'll just go into like a boot loop. So and when I saw that and then read about it, I was like, okay, so this is probably it. And it says processes in the question. That's not really like a giveaway, but it could have been. So with which legitimate process is it attempting to obfuscate? And we know that is CSRSS.exe. How many established connections did the process have active at the time of capture? So we can use something like the NetScan. Is it NetScan? Windows module. Very hard to read through this list. If you guys see something that says like Windows.network, NetScan, NetStat, maybe something like that. It's really hard to look through this crap.
There's driver scan.
In. Nothing else we can just look at. Well, we can grep for Windows. And I was hoping it would highlight it.
Oh, that's much better.
Windows. Huh? I don't see anything. Let's see if NetStat is a thing. Net scan. Let's go look at a cheat sheet. Volatility, PS scan, process dump, memory dump handles, DLLs, command line, net scan, Windows.net scan. Back. I don't know why it's not there. But anyway, wait, what? It is NetScan. Windows.net scan. Windows.net scan, Windows.netstat. So both of these should be working. I wonder if, let's do the source, volatility, ENV, then activate. So what I'm doing is I'm entering the virtual environment in which volatility lives. I created this with Python, like m, v, and v, and then opt volatility dot v and v. That way it'd be like a hidden folder in here. And then you just source it to actually activate the virtual environment. Now let's see what happens. Okay, I don't know. I guess there is a difference between not being in the virtual environment and being in it. So I guess if in the future you have a problem, have the same problem where you can't find all of the modules, then you should probably enable the virtual environment. So I guess specifically, I don't know if this will actually work. CRSS.exe. Hopefully it will, but it didn't seem like it did before, right? Like it helped with the help information, but it seemed like it wasn't actually used like grepping properly with the module. Awesome, so it did. And what was the question? Something about established connections? Yeah, how many established network connections did the process have at the time? So we've been able to grep, we can see 1, 2, 3 established processes. And see them connecting to, is it all the same IP? 108.133, 108.133. This one's different. 140.82, 114.5. Using the process ID identifier in the previous question, what is the name of the parent process? So I guess we need to go back to PS list, or let's try another module. Let's try PS tree. I'm not sure the difference visually, but hopefully it'll be easier to sort through as a tree. Nope.
Sure wasn't.
Nope. PS list. Let's go back to PS list. It's definitely pulling out a lot more information though, right? Like we can actually see full paths of PS tree process, like the command line and everything. Okay, so we have left side is process ID, right side is parent process ID. So we can see CRSS.exe has a parent process ID of CSRSS.exe 1560, which has a parent process of 1560 1560 explorer.exe. And then what is the full system path of the malicious process executable? So we know that PS-tree will help us out for sure. CRSS.exe. If we grep for that, hopefully it will spit it out in a format that we like and not miss the line. So that, I don't know, if it misses the line, we'll just add like before and after. Is this really the path? Like, how is it running? How is it running here? Maybe an administrator ran it? No shit. Right? Because it's like, how's the executable even going to get here? Like, whatever method is either being used for persistence, or the user that started the process must have been an administrator in order to even be able to write to C Windows system. And then we need to get the SHA-256 hashes for both malicious process executables. We can do this with, I know that we can pull the files out. Let's get a list of all these again. So we can actually pull the files out of memory and then run SHA-256 against it. And I'm not. Let me look back at my notes because I do not remember what the command is or what module it is that we need to use. Just it's not registry. We have like a -O or anything. But it's command line dump. Here we go. Okay, so we can use pstree, call the process ID, and then call dump. Pstree and our process IDs for this were 3076 and 5676. PID 3076, dump. Let's get the help information. Maybe not. So we can see the process list. Do we need an O option? We will just output it. Oh. No, that can't be it. Is that it? Whatever. We'll try, and then we'll add -- dump onto the end. Yeah. Filters URL output. I wonder if just doing -O without dump will provide us with anything. No. Clearly this is wrong. Command line. And yet here I am, using it multiple times. Windows.pstree. Let's see if any of these will show us what we can do to export I've dump files. Doesn't seem right. Let's take a look at the hint. PS list. -O for our current directory, and then dump. And we want the process ID of 3076. Awesome. What if we just call the location? Invalid argument. What if we say nothing? We do have a file. Okay. And then the other was 5676. 5676. And then we can just SHA-256 some them. Or should be able to. And that's cool. Okay. Let's see if they show up in virus total. As anything. That's wrong. Sky High, SWG, EXE. Let's get this other one. See if there are any other vendors. Calling it something. Just one. Behaves like a 164 dropper. Guess. Dropping malware. What is the name of the persistence run entry set by the malware? So we can call registry entries, or we can sort through registry entries. We can actually ask for registry keys with registry print key. And then let's attack H and just check what it needs. So it needs a key. And then we know that the run and the run once keys are what we're looking for, because it's looking for persistent run entries, which should be in software, Windows, maybe it's Microsoft. Microsoft, Windows, I think it's current version, run and run once. It may be Windows run software. Well, we'll figure it out. I guess this looks right. If we don't see anything here, which I already do, it's right here. We can see the persistence mechanism is the file being ran. Here, what was the question? What is the name of the persistence run file? So that goes last write time, hive offset, type, key, name, time, offset, type, key, and this is the name. What a crazy name. And that's it. That is that challenge. These modules are really cool. I don't know. I'm sure that we could do more and look through them. And I think that, I don't know, I think it might be worth looking deeper into the tool just to see what all I can do more. That's kind of why I put up all these cheat sheets. And I think I'm going to end up linking, well, I'm definitely going to link them into the chat. Even though most of them kind of seem to be redundant. It's just a lot of the same information distributed differently, so maybe I'll only put one or two in, but anyway, that's that whole thing. And that's also the end of all the challenges, like for the
Wow.
entire course.
That one was the easiest one of the bunch, I would say.
Mm-hmm.
Very straightforward.
Yeah, it's really cool. The only thing that's left is this incident response bit, and again, it's just kind of going over the stages of the incident response frameworks. I say frameworks, but that's one. Okay. That's it.
So different artifacts and evidence.
Oh god.
And this
It started talking to me.